Hi, I'm David with General Air. Today we're going to be talking about structural flux cord wire, E71T-8. Now that designator talks about the wire itself, what it does, the tensile strength, and the fluxes that are in it. This particular wire is Hobart XLR8. Now this wire was designed to replace 7018 out in the field. Most of people, when they think about steel construction or steel erection, will have a stick electrode, 7018 electrode holder, and that's the way that they've always done it. Well, this wire is designed to replace that. When they first came out, they were pretty miserable to run. They had a really bad what's called operator appeal. So when you're welding with them, they were just really hard to run. Well, due to advances in technology and flux, the modern structural wires, or we call them T8 wires, are really easy to run and have a great operator appeal. So today we're going to show you some tips and tricks on how to run this wire properly and get a really smooth bead. Now the first question that you'll get with structural flux cord wire is, where do I set my machine? What wire feed speed and what voltage? For these structural flux cord wires, I like to use the spec sheets that are listed on the manufacturer's website. You pick the brand, which in this case is Hobart XLR8, and you go to their spec sheet on their website. And then you pick out the diameter of wire that you're using and the position that you're going to be using for the setting here, and it's going to tell me my approximate wire feed speed and voltage, which in this case is 187 inches per minute and 27 volts. Wire feed speed dictates amperage and voltage is your bead profile. Now, you're smarter than the welder, so there's some fine tuning that could happen from these because not all situations are the same, but this is a good place to start. What I was talking about before was contact tip to work distance. That's the face of the contact tip to the work, or the edge of the wire. So in this case, 1 inch. Now this is very, very important with this wire. When we use a constant voltage machine and we change our contact tip to work distance, the voltage doesn't change, but what does is the amperage. So if we get too long, our amperage starts to drop out. If we get too short, the amperage starts to rise and the puddle gets erratic. Another thing that the flux cord wire uses is what's called preheat. So it needs that extra bit of distance to add more resistance to preheat the wire to get a good weld out of it. And one of the techniques that you would use with a structural flux cord wire is having a downward angle as you weld in an upward progression. This is different from most wires where you would keep an upward angle. This wire has so much flux in it that if you use a upward angle, the flux basically rolls over itself, causing your bead to be really erratic. So you want about a 10 to 15 degree downward angle, and then we'll weld up and we'll build ourselves a little slag shelf, and we'll ride that slag shelf all the way to the top. One of the ways that you know that you did a good job when you're welding with this wire is that the flux will just start to peel off on its own. That means you maintain that good downward angle and the flux floated to the surface. Now we're just going to pull this off, a little warm. Look at that, it's just one solid piece of flux.